The main purpose of this example is to demonstrate the design of chirped mirrors that must meet group delay dispersion (GDD) targets along with the demand for high reflection. In addition, the specification of spectral range targets is demonstrated. Before starting the example, it is worth to recall that the group delay (GD) and the group delay dispersion (GDD) are the first and second derivatives of the phase with respect to the circular frequency with a minus sign. In the File Arrow Project menu of OptiLayer, open the directory LEC25D14. Load into RAM the data files needed to run this exercise. These are the substrate glass N equals 1.52, the layer materials N equals 2.35, and N equals 1.46. In the target database, select the target file, chirped mirror 700 to 900 nanometers, GDD equals minus 55 femtoseconds squared, and choose Edit to view the contents of this file. The target requirement is for 100% reflectance in the 700 to 900 nanometer spectral range. In addition, there is a target requirement for minus 55 femtoseconds squared GDD in the same spectral range. Note that the tolerances DGDDRS column for assessing the closeness of the GDD to this value are set to 1 femtosecond squared. They are chosen in such a way to assign approximately equal weights to the two simultaneously specified requirements. There is also one more target file that will be discussed later. Load the target file, chirped mirror 700 to 900 nanometers, GDD equals minus 55 femtoseconds, squared into the RAM, and load the 49-layer quarter-wave mirror, QWM49 at 800 nanometers, as a starting design. Open the TNR and phase and GD and GDD windows to see the match between the R and GDD of the starting design and the target requirements. The loaded starting design has excellent reflectance in the required spectral range, but the GDD is far away from the specified target. To see the GDD of the starting design, you can choose the GDD scale from minus 65 to 20 fs squared. In the synthesis arrow options, select the SQP optimization method. Select the needle optimization auto mode from the synthesis menu and click the Run button. The result of optimization is a 46-layer design saved in the design database under the name CM by Needle with SQP. Click the Load button in the Needle Optimization window to load the obtained design into the General Information and Evaluation windows. In the TNR and phase window, change the R scale to 95 to 100%, and in the GD and GDD window, select the GDD scale from minus 65 to minus 45 femtoseconds squared. Note that the reflectance is below at the left part of the target spectral region, which should be avoided. The GD and GDD window shows fluctuations in the group delay dispersion. It can be theoretically shown that such fluctuations are inevitable in the high reflection region. Knowing that GDD fluctuations are inevitable can help to reformulate the design problem more realistically. If a certain level of fluctuations is acceptable, then the design problem can be set as follows. Let us design a mirror with the highest possible reflectivity in the considered wavelength range, provided that the GDD fluctuations do not exceed an acceptable level. The acceptable level of the GDD fluctuations can be specified using range spectral targets. An example of such a target is stored in the target database under the name range target from minus 58 to minus 52 femtoseconds squared. Use Edit tab to examine this target. It specifies the acceptable GDD fluctuations from the initial target value of -55. Load the range target into RAM. Note that the MF value in the lower left part of the needle optimization window has been reduced due to the new relaxed target requirements. Click the Run button to start a new optimization procedure. The obtained design is stored in the design database under the name CM by needle with SQP and range target. Click the Load button in the needle optimization window to load the obtained design into the General Information and Evaluation windows. The T&R and phase window shows that the reflectance is now higher than 99.9% over the entire range from 700 to 900 nanometers. The GD and GDD window shows that the GDD fluctuations have increased, but they do not exceed the level specified by the range target.